Hello students, today I'm going to discuss January attempt JEE Mains paper 2023. It is 31st January morning batch. So I'll discuss chemistry paper. So in first question, chemistry section, there is a reaction propanol methanol with dilute NaOH and other reagents and gives product B. Formula of product B is given and we need to find the correct statement about the product B. So we'll start with the reaction propanol. So it is CH3, CH2, CHO and methanol HCHO with dilute NaOH. It will give cross aldol condensation. So dilute NaOH. So cross aldol condensation, the product will be alpha beta unsaturated aldehyde. So CS3, CHO double bond CH2. Now in the next step, we are using NaCN. NaCN. The CN minus is nucleophile here. It will attack the aldehyde group and it will form cyanohydrine. CH3, C double bond CH2, C OH, here CN. Now after hydrolysis, in the next step, hydrolysis of cyano group will take place and it will form carboxylic acid. So we are using hydrolysis in acidic medium. So it is CH3 double bond CH2 OH and C double O H. Okay. So we can match the formula of B also, that the same formula is there. Now we talk about the optical activity. Now when this cyanohydrine is attacking HCHO group, so this carbon is a chiral carbon now, because 4 different groups are present on this carbon, and new chiral carbon, whenever new chiral carbon forms, so there is a possibility of both the isomers, okay, R or S configuration, both are possible for this. So it means the final product is mixture of both the isomers. So DL mixture, DL mixture. So it means it is a racemic mixture. So option 1 and 2 are eliminated. They are not the answer. So option 3rd says the mixture is neutral. No, because there is a COOH group. So mixture is acidic. So it means option 4 is correct, because in acidic medium NaHCO3 gives CO2 gas. So that is why option 4 is correct. The next question is, we need to find the correct order of ionic radii. So these are isoelectronic species which we need to compare. So it is easy for us to compare isoelectronic species. So in all these species, there are 18 electrons. So calcium has maximum number of protons. So effective nuclear charge of Ca plus 2 is maximum, and sulfur has minimum number of protons. So Z effective is minimum for sulfur atom in this. Okay, so S minus 2 minimum Z effective. That is why size of S minus 2 will be maximum, because number of electrons are same. In each, there are 18 electrons. So option 4 is correct. Okay, then next question number 3. So question number 3 says H2O2 acts as reducing agent in. Now we'll start with option 1. NaOCl and H2O2 reacts. Here oxidation number of chlorine is +1, and in this oxidation number of chlorine is -1. Okay, so reduction of chlorine is taking place and H2O2 is going to O2. Oxidation of H2O2 is taking place. It means H2O2 is acting as a reducing agent in the reaction 1. So this is the answer for question number 3. Okay, next question. A protein X with molecular weight of 70,000 U on hydrolysis gives amino acids. One of these amino acid is. Now, proteins are basically polymers of alpha amino acids. Okay. Proteins are polymers of alpha amino acids. Alpha. So when we do the hydrolysis, this polymer will break and will give alpha amino acids. Okay. So out of these, only third one is the alpha amino acid. So COOH, its alpha position. Here NH2 group is attached. So option 3 is the answer for this question. And question number 5, next question. We need to identify X, Y, Z in this equation. Now we have a radical, ClO radical. So there is an odd electron here, and in NO2 also there is a odd electron. So when we react these two, they will form a bond and we'll get ClO NO2. So this is our X. Then on hydrolysis, on reaction with water, hydrolysis of this will take place like this. So this hydrogen will go with ClO and it will form HOCl and HNO3. So Y and Z. So what's the answer? Option second. Yes, option second is the answer. ClO and HOCl HNO3. Then question number 6. Now, an organic compound A with empirical formula C6H6O gives sooty flame on burning. Now, sooty flame, aromatic compounds gives sooty flame on burning. So now we can guess this formula is for aromatic compound. There is a aromatic arrangement. Okay, so benzene ring might be there. Then its reaction with bromine solution in low polarity solvent. Now, low polarity solvents like CS2 dipole moment for CS2 is 0, mu is 0. So it is a low polarity solvent. Results in high yield of B. Now, the major product we need to identify. So in low polarity solvent, phenol reacts with bromine to give para product, para substituted product. So option 2 is the answer. Question number 7. Okay. So now this is the question. Matrix match. We need to match these column A versus, with column B, column 1 versus column 2. So we'll start with this crystallization. So crystallization is used for to separate two solid compounds. Okay, so here we have, this is the formula of glucose or sucrose, and NaCl is there. So glucose and NaCl both are solids. So to separate these, we can use crystallization. So for D, the first option will match. So in first and third, we can say out of these two, there will be an answer. Then next, we match the A option. So in A option, H2O water and CH2, Cl2 is there. To separate these two, basically H2O is a polar solvent, and CH2, Cl2 is an organic compound. So we can use differential solvent extraction for this. In this technique, what we do is we use a organic solvent where CH2Cl2 is more soluble than water. So easily we can separate H2O and CH2Cl2. So with option A, there is second is matching. So option 1 is the answer, we can directly say. Then if we want to check the other, so in B, there are two compounds, and one compound there is a OH bond, so hydrogen bonding, this compound may form hydrogen bonding. The other compound will not form hydrogen bonding. So absorption of the second compound will be more on adsorbent. So column chromatography method can be used because they have different tendency for the adsorption. So with B, we can match the third one. So option 1 is the answer. Moving to the next question, question number 8. Okay, we need to match the structures of these compounds, shapes of these compounds. Now XeF2, it has geometry, octahedral geometry, Xe, but the shape is square planar because lone pairs are present like this. So in the first one, square planar shape. So with A option, we can match the second one. Then B, SF4. SF4 geometry is a trigonal bipyramidal. So in trigonal bipyramidal system, this is sulfur atom, one fluorine, another fluorine, and this fluorine, and one lone pair is there. One lone pair is there. So we have a seesaw structure. We will match with the first one, NH4 plus tetrahedral. So NH4 plus tetrahedral structure. Now I think we can guess the answer, which option is the correct. So with A, we are matching the second one. So out of second and third, option 1 is correct. Then with C, tetrahedral, C, we will match the fourth one. So option 3 is the answer. C matches with the fourth tetrahedral. Now shape of BrF3 is band shape. Geometry is basically trigonal bipyramidal only. Let me just draw the structure of this also. This has two lone pairs and three bond pairs. Bromine, two lone pairs, F, F, and F. So this is how it has a bent T-shaped structure. Question number 9. Which one of the following statement is correct for electrolysis of brine solution? Now, when we do electrolysis of aqueous NaCl, so at anode, oxidation of Cl minus will take place. At anode, oxidation, and it will form Cl2, and at cathode, reduction of water will take place. So 2 electrons, it will give hydrogen gas and 2 OH minus. Now what are the options? H2 is formed at anode, which is incorrect. Cl2 is formed at cathode, it is also incorrect. OH minus is formed at cathode, okay, which is correct. So option 3 is correct in question number 9. Okay. Question number 10. So question number 10, choose the correct set of reagent for the following conversion. We need to convert from trans alkene to cis alkene. Let me write this. pH, H double bond C, H and CH3. This is a trans alkene. Now let us check the reagents. Now when we react it with bromine Br2, Br2 will add by anti-addition mechanism. So anti-addition will take place. pH, C, H, Br, C. Now next is, now we need to convert it into cis alkene. So next we need a elimination step. So we can use alcoholic KOH for the elimination. Now alcoholic KOH. So it will eliminate one HBr from here. Will form pH, C, Br, double bond, H, CH3. Okay. In the next step, NH2 is used. It will again eliminate HBr, SN2 mechanism, E2 mechanism, and it will form an alkyne. Now we have an alkyne. Now, next reagent. Now, alkyne with Lindlar's catalyst gives cis alkene, because in this syn addition of H2 take place and it will reduce up to alkene only. So we will get the cis product. This is cis product. It means option 4 is correct in question number 10. Next is question number 11. Adding surfactant in non-polar solvent, the micelle structure will look like. So this is the round part is the polar head, and this is the non-polar tail of this surfactant. Now, because solvent is non-polar, so this non-polar tail will be in the solvent side and outward side. Okay, so option this A structure is the correct representation for this condition. So option 2 is the correct answer for this. And question number 12. The correct order of melting points of dichlorobenzene is. Now, melting point depends on the packing of the solid. So, in a solid which is very closely packed and packing is good, then melting point will be more. So, in this question, option A will be the answer. This is the first option is the answer. Question number 13. When Cu plus 2 ion titrated with Ki, a white precipitate is formed. Okay. Now, in this, Ki will act as reducing agent and it will form Cu2I2. So, plus I2. This is X. The solution is titrated with sodium thiosulfate. Now, when the solution is titrated with sodium thiosulfate, the compound Y is formed. Now, this I2 will react with this sodium thiosulfate, I2 with Na2 as 2O3, and it will give 2 NaI and Na2 as 4O6. So this is basically a reaction we use in iodometry titration. So we need to identify X, that is U2I2, and Y is Na2 as 4O6. So option 4 is the answer for this question. Question number 14th. Which transition in hydrogen spectrum would have the same wavelength as the Balmer type transition from 4 to 2 in helium plus spectrum? Now, same wavelength, if there is same energy difference in orbitals, then wavelength will also be same. So, formula for energy difference delta E is equals to minus 13.6 Z square into 1 upon N1 square minus 1 upon N2 square in electron volt per atom. Okay. Now, if we put the value of N and for helium Z is equals to 2, so we are going to get minus 13.6 into 4, 1 upon 2 square means 4 and 1 upon 4 square means 16. So if we take 4 common from here, so we'll get minus 13.6 into 1. 1 upon 1 minus 1 upon 4. So for hydrogen atom, Z is equals to 1. So we can compare this with delta E of hydrogen. Okay, because hydrogen, for hydrogen atom is Z is equals to 1. So N1 and N2 is 1 and 2. So for transition from N equals to 2 to N equals to 1, the same wavelength we will get. So option 2 is the answer here. And question number 15. The correct order of basicity of oxides of vanadium. Now, as the oxidation number of metal increases, acidic nature of their oxide increases. Okay, so oxidation number increases, acidic nature also increases. So where oxidation number is maximum, that is most acidic and least basic. So option 1 is the correct answer. So oxidation number of vanadium is minimum in V2O3, then V2O4, then V2O5. Question number 16. Which of the following artificial sweetener has the highest sweetness value in comparison to cane sugar? Now, artificial sweeteners, this Elitem has the maximum sweetness value in comparison to cane sugar. So if we compare the sweetness, then saccharine has the sweetness value of 550. Okay. And this Elitem has sweetness value of 2000, about 2000. So option 3 is the answer. And question number 17. Cobalt chloride, when dissolved in water, forms a pink colored complex X which has a octahedral geometry. So octahedral geometry means 6 water molecules will be there in the coordination sphere. This solution on treatment with concentrated HCl form a deep blue color complex. Now, with this color, we can guess the geometry is changing when we reacted with concentrated HCl, because octahedral complexes shows a lighter color, but the tetrahedral complexes shows the deep color and dark color. So we can guess the final structure will be tetrahedral, and 4 ligands will be there. So option 2 is the most appropriate for this. So question number 17. Question number 18. The methods not involved in concentration of ore. This question is from metallurgy chapter. So concentration of ore, we can use liquation. Liquation, no, this is not used for concentration. So one is liquation, then leaching can be used. Electrolysis also we do not use in the concentration. We can use it in purification. So A and C. Then hydraulic washing, okay, we use in concentration, and flow flotation is also concentration. So we need to choose those which are not involved in concentration. So option 3rd, A and C, both are not used in concentration process. So 3rd is there. Question number 19. Okay, this is F block element. So electronic configuration of this is outer shell configuration is 4f4 and 6s2. So in plus 2 oxidation state, outermost shell electron will go out and D plus 2 will be 4f4. Option 3 is the correct answer. Question number 20. Okay. Now in this, a organic reaction is given. So in first step, reduction will take place. Nitrogen containing compound. So reduction will take place and it will form aniline. So A is the aniline here. NH2. Then we are using anhydride to react with aniline in presence of pyridine. CH3, C, double bond O, CH3. Now in the aniline, this lone pair of nitrogen will attack on this carbon and this bond will break. So this nitrogen will attach with this COCS3. So option 2 is the answer for this question. Product B is this one. Question number 21. Now it is section 2, numerical type questions, integer type. Okay. The logarithm of equilibrium constant for this reaction, we need to give answer in the nearest integer value. Now for this reaction, value of E naught is not given. We need to calculate E naught value first. So if we can use these two reactions to get E naught value of this third reaction. We can subtract reaction 2 minus reaction 1. So PD plus 2 electrons. Solid. And if we subtract it, it will be PD solid 4Cl minus gives PdCl4 minus 2 and 2 electrons. In both the reaction, 2 electrons are there. They will cancel out and we will get this equation. Pd plus 2 is 4Cl minus is PdCl4 minus 2. Now we can use this formula because E naught is not additive in nature. E naught value is not additive in nature. So we can directly do not add E naught. We can find delta G naught, which is minus NF E naught. N is number of electron, F is Faraday's constant, and E naught the value. So delta G for the third reaction is equals to delta G for first reaction minus delta G for second reaction. So delta G3 is equals to delta G naught for first minus delta G naught for second. When we put the value here, in the third reaction, 2 electrons are exchanged to minus 2F, and E naught for the third reaction is equals to minus 2F E naught of the first plus 2F E naught of the second. Now 2F will come out common, and finally we will get the value of E naught for the third reaction. It is equals to 0.18. So 0.83 minus 0.65, 0.18 is the value. Now we need to calculate K equilibrium, logarithm of K equilibrium, log value of K equilibrium. Okay. So because this is a equilibrium, so E cell will be 0. If we use Nernst's equation, E cell equals to E naught cell minus 2.303 RT upon NF log K equilibrium. For K equilibrium, this is 0, and the value of log K equilibrium is equals to 0.18 E naught divided by the value of 2.303 RT by F is 0.06. So N is number of electron. So when we divide it by 2, we will get 0.03. So 0.03. So logarithm of K equilibrium is equals to 6. So for this question, answer is 6. Question number 22. The total pressure of a mixture of non-reacting gases. Now, there are two gases, X and Y. Mass of the gases is given in the vessel, and total pressure is given in mm of Hg. We need to calculate partial pressure of the X gas. So first we will calculate the moles of these two gases. So moles of X are mass upon molar mass, that is 20, and moles of gas Y is 0.45 upon molar mass is 45. So here we will get 3 into 10 raised to power minus 2 moles, and here 1 into 10 raised to power minus 2. So mole fraction of X is equals to 3 into 10 raised to power minus 2 upon total moles, that is 4 into 10 raised to power minus 2. So 3 by 4 is the mole fraction. So partial pressure of X is equals to mole fraction of X into P total. Dalton's law of partial pressure. So partial pressure of X is equals to 3 by 4 into 740. 740. So we will get 555 value here for the partial pressure. So 5 mm of Hg. So this is the answer for question number 22. Question number 23. Now in question number 23, it is a question from solution chapter. So solution containing 2.5 gram of solute in 250 ml of solution. So mass of solute is given, volume of solution is given, and exert osmotic pressure of this. Osmotic pressure is also given. The molar mass of solute we need to calculate. So we know the formula for osmotic pressure, that is pi is equals to CRT, where C is concentration, moles per liter, pi is osmotic pressure. So the value of osmotic pressure is 400 Pascal. Concentration. So we have mass of solute. So mass divided by molar mass is equals to number of moles. So we can divide this mass by molar mass, and these are number of moles. Now number of moles divided by volume in liter, so that is 1 by 4. So 4 will be multiplied here. Then value of R, it is given in the question, 0.083, and T is temperature, which is 27 degrees Celsius. We will convert in Kelvin, so 300 Kelvin. Now, since R is given in unit, liter into bar per Kelvin per mole, and here we have pressure in Pascal. So we can convert this Pascal into bar unit. So unit in the both sides should be same. So 1 bar is basically 10 raised to power 5 Pascal. So either we can convert the bar into Pascal or Pascal into bar. We can do either of the two. So we have molar mass is equals to 2.5 into 4, 0.083 into 300 divided by 400 into 10 raised to power minus 5. Now this is in bar. So the molar mass of this compound will be, on calculation we'll get 62,250. This is the molar mass of the compound. Okay, then question number 24. This can be a polymer maybe, because molar mass of compound is too high. So this can be a polymer. Okay. Now question number 24 says the oxidation state of phosphorus in hypophosphoric acid is. So in hypophosphoric, the structure of hypophosphoric acid is this: OH, OH. Now we can easily calculate the oxidation state of phosphorus here. Now phosphorus is attached with this oxygen with double bond, and here single bond and single bond. So overall oxidation state of this phosphorus is +4, and this phosphorus is also +4. So answer is 4 in this question. And question number 25. Now we have a reaction A to B. The rate constant of the above reaction at two different temperature are this and this respectively. The activation energy for the reaction, in the nearest integer we need to give the answer. So formula for this is log the rate constant for the second reaction divided by rate constant of first reaction equals to activation energy divided by 2.3 1 upon T1 minus 1 upon T2. Okay. So when we put the value, because all the values are given here, log K2 is let's say 0.05 and K1 is 0.03 is equals to EA upon 2.3 1 upon 300. Okay, 1 upon 200. T1 is there first. So 1 upon 200 minus 1 upon 300. Now, we also have the value of log 5. So here point will be removed and we can write it like this: log 5 minus log 3. Okay, so the value of log 5 is given 0.70 and log 3 is also given. Now on calculation, we will get the value of EA. So here we'll get 1 upon 600 the value of activation energy in the question is 2520. Now when we calculate, we'll get this value. So it is an easy question. Just all the values are given. Then question number 26. On complete combustion, 0.492 gram of an organic compound. Now we have an organic compound. Mass of the compound is given 0.492. Now when we do combustion and complete combustion, we get CO2 and H2O. So CO2 is given, mass of CO2 is 0.792. Now, what we need to calculate? Percentage carbon in the organic compound. We can calculate moles of CO2 here from here, because mass upon molar mass is equals to number of moles. So moles of CO2, we will get the value 0.018. Now, moles, because in one CO2 molecule, there is one carbon atom. So moles of CO2 and moles of carbon is equal. So moles of carbon is equals to 0.018. So we can find the mass of carbon by multiplying it by molar mass of carbon. So mass of carbon is 0.018 into 12. So percentage of carbon in the organic compound. So mass of carbon 0.018 into 12 divided by mass of the compound, which is given 0.492 into 100. Now, on calculation, we will get the percentage of carbon, which is equals to 44%. Okay. Then question number 27. Zinc reacts with hydrochloric acid. Zinc with HCl to give hydrogen and zinc chloride. So ZnCl2 and H2 gas. Okay. The volume of hydrogen gas produced at STP from the reaction of this much gram of zinc. Mass of zinc is given 1.5 gram with excess of HCl. Nearest integer we need to give the answer. Now this is simple question of mole analysis. So mass of zinc is given. We can find the moles of zinc by dividing it by molar mass. That is 65.4 grams per mole. So we will get moles of zinc equals to 0.175. Since stoichiometric coefficient of zinc is 1 and stoichiometric coefficient of hydrogen is also 1, same stoichiometric coefficient, so moles of both the species will be same. So moles of hydrogen is also 0.175 mole. Now number of moles are given and molar volume of any gas at STP is 22.7. So volume of these many moles of hydrogen, VH2, volume of hydrogen is number of moles into molar volume. So molar volume 22.7 liter per mole. So we will get the volume of hydrogen gas here. It is 4 liter. Next, question number 28. Now, for the reaction SO2, half O2 to SO3, Kp is given and 1 atm pressure. Kc for the same reaction is, okay, we need to calculate Kc. So there is a relation between Kp and Kc. Kp is equals to Kc into RT raised to power delta and G, change in moles of the gas in the reaction. Now here for this reaction, delta Ng is equals to minus 1 by 2 because in product side there is 1 mole of gas and in reactant side there is 1.5 moles of gas. So delta Ng is minus 1 by 2. So Kp, it is 2.2 into 10 raised to power 12 equals to Kc. We need to find the Kc. Value of R is given 0.082. Temperature is 300 Kelvin raised to power minus 1 by 2. Now we'll get the Kc value equals to 1 into 10 raised to power 13. Okay. Now the multiply of 10 raised to power 13, we need to calculate this coefficient, that is 1. So for question number 28, answer is 1. And question number 29. Okay. Now, how many of the transformations given below would result in aromatic amines? Okay. So aromatic amines in which reaction we'll get? So first reaction, when we observe this is a amide reacting with bromine and NaOH. So this reaction will be Hofmann-bromamide reaction and definitely will get a aromatic amine in this reaction, Hofmann-bromamide reaction. So we'll get aniline in the reaction 1. So for reaction 1, this is the product. In reaction 2, there will be no reaction here because aryl halide is there. So nucleophile cannot remove this Cl very easily. So there is no reaction. Then in third one, reduction will take place. NO2 nitro group will be reduced by H2PDC, and again we'll get the aniline product. Same product we'll get. So it is an aromatic amine. Then the fourth one, there is a hydrolysis. In this fourth step, hydrolysis is taking place. So on hydrolysis, this will break into aniline and carboxylic acid. So again, we get aniline as a product. CH3, C double bond O, OH. So out of these four, 3 reactions are giving aromatic amine as a product. So answer for this is 3. The last question is the 30th question. The enthalpy change for the conversion of half Cl2 to Cl minus. So we need to calculate enthalpy change for this reaction, half Cl2 gas to Cl minus, okay, to Cl minus aqueous. So delta H1, let's say it is delta H1 for changing for this reaction. Now first we need to break the bond of Cl atom. So we need bond dissociation energy, which is given as 240 kilojoule per mole. So for one Cl2 molecule, 240 kilojoule energy is there. We only need half Cl2 means one Cl atom. So bond energy here we need is 120 kilojoule only, and we will get Cl gas. The next is electron gain enthalpy for Cl is given. Now Cl gas to Cl minus gas, electron gain enthalpy is given, that is minus 350, because energy is released, so minus sign will be there, minus 350 kilojoule per mole. Now from Cl minus to Cl minus aqueous, Cl minus gaseous to aqueous, so hydration will take place, and hydration energy is minus 380. It is also exothermic process, so we can use Hess law. We can directly go from here to here, or we can use another method. Overall enthalpy change is going to be same. So delta H1 must be equals to 120 plus here minus 350 and minus 380. So we will get the value of delta H here 610. The delta H for this reaction is 610 kilojoule. So this is the chemistry section for 31st January morning session. Thank you.